Okay, here are a couple of solutions to problems off of the practice problems for test 3. Under part 1, I believe we did the first one, but in number 2, remember what we're trying to do here is find an antiderivative of what we call the integrand, this stuff. So antiderivative of 6x squared is, not used to writing with this pen, hang on, I gotta make bigger numbers, is 2x cubed. It's easy to stop and think about the derivative of 2x cubed is 6x squared. And then the antiderivative of 1 over x is just natural log of x. So this is an antiderivative of the integrand that should be evaluated between 1 and 3. And so I first can put 3 in for x, that's 2 times 3 cubed, that's 54, minus natural log of 3, minus, putting in 1 in for x, 2 times 1 cubed is 2, minus natural log of 1. Natural log of 1 is actually 0, so that's nice. So now I have to do 54 minus log of 3 minus 2. So that's equal to 54 minus 2 is 52 minus the natural log of 3. So that's the answer to problem number 2. For problem 3, again, we need an antiderivative. So an antiderivative in this case is going to be 6 times e to the 0.5x. So these are just using our antiderivative rules. The one I'm using here is the one that says if you want an antiderivative of e to the kx, the answer will just be e to the kx, but with the reciprocal of k out in front, so plus c. And so 1 over the reciprocal of 0.5 is 2, so if I have 3 times the reciprocal of 1/2, that's 6. And again, it's very easy to take the derivative of this and see that it really is equal to the integrand. So we can always check our antiderivatives using our derivative rules. So this needs to be evaluated between 0 and 4. So if I plug in 4, I'll have 6 e to the 2. And if I plug in 0, I will have 6 e to the 0. And so e to the 0 is 1. That's actually the same fact up here that told us that log of 1 was 0. It's the inverse of that. So 6e squared minus 6 would be as much as we could do with that without getting out a calculator and then getting an approximation. So those are the answers for number 2. If I move on to the next page, part 3, this is another one that we didn't do in class, but it's not too hard. We know that the answer to the integral here will be, and the answer to the problem is going to be this definite integral. So the integral is going to be whatever x value we're starting at, that's here, all the way over to the x value that you're ending at. So that'll be the limits of integration. This computer almost quit on me there. And so I claim that that's minus 3/2 to 1. If you want to check that, that comes from, if you don't have a picture that's easy to read, or you just want to make sure, that comes from solving the equation that you get by setting the two equations equal to each other. So if they're going to have common coordinates, that means the x's and the y's have to be the same. If the y's are the same, that means that the two right-hand sides have to be equal. And so this has to be true. So if we solve this, this is a quadratic polynomial, so I would add stuff from the left side over to the right side so that I have 0 on one side and everything else on the other. So 2x squared plus x minus 3. And then I would factor that guy. That's 2x plus 3 times x minus 1. Or you could use the quadratic formula, but obviously the roots here are x equals negative 3/2 and x equals 1. So if I kind of know that from the picture, or kind of think that might be true, then it's a lot easier to factor because I'm just trying to verify that that really is true. All right, so those are my limits of integration. We know that we're going to have top minus bottom. That's how we set up our integrand. So we need to know which curve is which. It's very easy to just take a point like x equals 0. That's definitely in here, and see which of these two curves has the higher y-coordinate. If you put 0 into the first formula, this gives you 4. So obviously this is the point that came from this curve because it has 0, 4 on it. And this point is 0, 1. That comes from this curve. So the 4 minus x squared is the top curve, and the x squared plus x plus 1 is the bottom curve. So I would be integrating the difference between these two things. And so don't forget you have to subtract the entire top formula minus the entire bottom formula. So we add parentheses for that. If I clear the parentheses out now, I'll have 4 minus 1 is 3. I'll have a minus x, and I'll have minus 2x squared. So that's just simplifying the integrand, and then I can do the antiderivative and evaluate it between -3/2 and 1. And again, the answers to these are posted online on the online version of this, so you can see that to see what number I got for that final answer. And then finally, no, I think we did that one in class. Okay, so those are the ones that we didn't do in class. If you have questions on other ones, send me an email. But don't forget that the solutions are the version that is pasted in MyLabs Plus has the answers in it. So if you just need to check a final answer, check there. And if you have a question about how a step happened, just send me a specific question about that, and I'm sure I'll have a chance to answer that.